Welcome back to the Joy of Programming, everybody. I'm Chris Jordan, and in today's episode, lecture number 22, we're going to be painting some happy little trees together. The only materials you'll need for this episode are VS Code, a blank canvas in your Chrome web browser, and your imagination. So let's jump right in. All right, so the first thing that we want to teach our little program how to do is to make a happy little brush stroke, right? And what we'd like to be able to do is draw a line out and then draw a line to come back in. So we need the ability to stroke out and then to bring our turtle right back to where it came from and reset itself. And we'll do this many times over as we're drawing our happy little tree, right? And luckily the turtle makes a much happier looking tree than I can with my pen. And so let's try jumping right in and defining a function named Lineout as we're stroking our turtle graphics out onto the canvas before us. This will have an angle parameter of type number. This will be defined in terms of radians, our good friends radians. Who wants 1 pi when you can have 2? And a length parameter when we are going to tell it how long we want this stroke line out to be. This is going to be a void function. We'll come back in as a separate function as we return to where we came back from in our drawing. So we're going to turn left by an angle and we're going to move forward by our length. And so this should feel very familiar. This is much like the function we wrote in the previous example. And what we'd like to be able to do is return our turtle right back to where it came from. We don't want to leave any state left on the canvas. We want to have our turtle in a place that it can keep making progress from where it should. So we're going to define this function just like we did before in the Lineout function, and it's going to be the inverse of it. So what we'd like to be able to do is say, hey, make a stroke out on our canvas and then bring that canvas turtle right back to where it started. So the first thing we're going to need to do is turn around, right? So we need to get that turtle all the way facing back in the other direction, no matter what direction it's currently facing in, right? So we're going to turn that turtle left by not the angle, but by math.pi over 2, right? And not math.pi over 2, right? Oh no, that would have been a happy little mistake. We're going to turn our turtle around by math.pi. That's 180 degrees, right? So if 2 pi is a full 360, 1 pi is turning right around and facing the other direction. And then we're going to move the turtle back that whole length that we came from. And finally, we're going to turn the turtle back around and then add on the angle that we started with, right? So I'll explain this in just one moment, right? So we're going to turn the turtle left by 1 pi plus this angle. So how do we imagine this line out and line back? Well, let's imagine our turtle is initially facing in this direction, right? So this is the starting direction. And we wanted to turn the turtle by 90 degrees, say, and have it facing upwards. And then draw it moving forward by some amount, like maybe 100. We can imagine this is what happens in the line out function call. Well, what if we wanted to get the turtle right back into its initial state? Well, then we would need to turn the turtle around by 180 degrees, which is what we're doing here. Bring the turtle forward again by the length that we went before. And now our turtle's facing in this direction. If we turn the turtle around by 180 degrees alone, it would be facing back up. But what we really want to do is turn the turtle in the direction of it was facing before. And in fact, by thinking through this code, what I've realized, if we draw this out, if I turned left again, we would have turned and been facing in the opposite direction. So we want this to be the opposite of the turn that we made initially. So let's try making this turning right by math.pi. And sometimes when you sketch things out, you realize you made a little mistake, and that's okay. We can always fix this in code, all right? So we're turning back around, and let's see what we've got here. We've got the ability to stroke out and then come back. Well, turtles, if they're trying to make trees, we need to teach a turtle how to draw a branch, right? So let's try defining a function named drawBranch. And to draw a branch, what we're going to do is say, what's the direction that this turtle is going to be drawing in? This will be the angle it's facing. And what is the length of this branch going to be, right? And this will be, once again, a void function. And as we're making these drawings, we're leaving it all on the canvas. We're not trying to return anything back to the caller. So what is a branch going to look like? Well, we can imagine this in a sequence of line out in some direction and some length, and then a line right back, right? So we're going to define line branch in terms of the two functions we just wrote. So a line out and a line back. And we think of this just like stroking the brush up and stroking the brush right back to where it started. All right. Now from here, let's try seeing if we can draw a tree. And we're going to think, well, if a tree is made up of many branches, maybe we should draw a tree. And so our tree is going to be positioned at some X number location and some Y number location. This will be the position on our canvas that we want to plant one of these happy little trees, right? So what is a tree going to do? Well, let's just move our turtle to this position. Right? We're going to move our brush to this X and Y coordinate position. And then we're going to draw a branch, right? So draw a branch. And how are we going to draw this branch? Well, the first direction that we want a turtle to face in, if our turtle starts to the right, is we want to turn it by 90 degrees so that, we want our branches to grow out from the ground. That's typically towards the heavens, that we want our branches to experience life looking up and out into the world. So we're going to add a math.pi/2 for 90 degrees and make this first branch, a big, healthy branch, 300 pixels long. All right, well, let's try drawing a tree now, shall we? Draw a tree. And where do we want to place this tree? Well, maybe we place it at, I don't know, let's just pick a number, 150 on the x-axis and 300 on the y-axis. That's totally fine. Whoa, that's quite a large tree. So maybe we should make this a little bit smaller here. I don't know, maybe 100 seems like the right amount. Okay, that's a nice little branch, but this sure looks like a barren tree, right? This looks like a tree that somebody's chopped down. And it was just Earth Day yesterday, so maybe we shouldn't chop down our trees. Maybe we should think about letting them flourish in our little program here. So how can we draw branches that don't just stop with one? They grow out from one another. Well, let's think about this. If we make this idea of a branch recursive, right? Well, a branch is not just this branch, but it's also a branch to the left, right? And maybe that branch is also a branch to the left. We can start to think of this as a recursively drawn process. So where do we go from here? Well, why don't we try adding a base case here? And our base case is going to be if the length of a branch is just so small, like maybe less than 5, then we've reached a leaf, a beautiful little leaf. And this is our base case, right? We'll just leave the leaves as we won't have any leaves right now. We'll pretend it's still winter. But let's think about the recursive case. All right, so I'm going to cut these two lines that I've got here, drop them into my else branch. And what we want to be able to do is after we draw a line out, right, we don't want to stop there. We want to draw another branch, right? So maybe we draw another branch. And this is recursion, right? We're drawing a branch, and now, well, what direction do we want to draw it in? Now, if we think about the turtle facing in one direction, we kind of want to turn it just a little bit to the left, say. And that's what's going to happen when we do this line out. So maybe we do this math.pi/6, something like that. So not a full 180, in fact, 1/6 of a 180. And we're going to draw this in some length direction, right? So remember, if our base case is our length, we need to be making this a little bit smaller each time. So maybe we take our length and multiply it by something like 77%, right? So we scale this a little bit down. And let's see what happens. Wow, look at that beautiful little branch we've got there. Maybe we'll make this a little bit shorter, all right? And okay, that's pretty nice. And maybe we should move it a little bit over. It's running off the canvas. No one likes to have a tree run right off the canvas like that. So, there we go. That's pretty nice. So where do we go from here? Well, this is, it seems like we're recurring in one direction here. But wouldn't it be nice if our tree didn't just look like it was growing towards the sun in one direction, but we grew it out in multiple directions, and then each of these branches also grew out a little bit? Well, this is a horrible looking tree that I'm drawing right now, but that's because I drew it myself. I should have let the program do it for me. Why don't we try adding a branch in the other direction, right? So how might we do that? Well, let's just add another call to draw branch here, and math.pi/6, that causes our turtle to turn in the leftward direction. What if we made this negative and said, negative instead? That might cause the turtle to turn in the opposite direction, the negative direction, right? Well, maybe we don't want this to look uniform, but we'll come back and think about that later. And maybe we make this length times 0.75 as well. That seemed like a fine way. What that means is each branch we draw is 3/4 the length of the one that came before it, right? So, okay, well, let's see what happens when the computer draws this little tree. Wow, look at that. Recursion really coming to life right before our eyes. I should move this tree over a little bit more, maybe 300. 300 would be the right place for it. And maybe 400 down. It was starting to go off the top of the screen even. This is a vibrant, beautiful big tree that we're drawing here on our screen. Look at that recursion go. And I want you to think about how many steps this recursive process is taking to get to the end of it, right? Each recursive call isn't leading to just one other function call, it's leading to 2 other function calls. So that means each branch here is doubling the number of functions it calls each time another branch gets called. That leads to quite an exponential growth, right? We're growing by each time we make a step, we're doubling the number of steps that come after us until we reach our base case, right? So this winds up being okay once we get to our base case. But look at that. We've written maybe 30 lines of code here, and the result is this beautiful little tree. Well, it's nice to be able to paint a tree like this and to see it come to life. But maybe we want this to be a little bit faster. So we want this to be something that shows up immediately. So maybe we do number max value here, right? And so boom, look at that tree. It just came to life like that. And this tree, it feels a little bit, it doesn't feel very organic. So maybe we change some parameters here. We make the right side grow a little bit less than the left side, or turn a little bit less to the right than the left. And so you see there's a little bit of a lean there. Maybe we shorten it a little bit more on the left side, right? So maybe we do like 0.7 here. And now we're getting a slightly different looking tree. Well, we're here in the joy of programming. It's nice to have one tree, but it'd be great if we could paint a little scene here, right? Well, one of the functions that's in this turtle library is named setOnClick. And setOnClick is a higher order function. It's a function that we can give the name of another function that takes 2 parameters, an X and a Y parameter, and it will call that whenever we click our canvas and give it those 2 X and Y values. Right? So if we say setOnClick draw tree, this will mean that every time we click, we've told the turtle library, hey, call this draw tree function. And so now if we click in our scene, we're planting little trees all over. And look at that beautiful, beautiful painting coming together. Well, these trees, they're all the same size. What if we wanted to make the size of our tree smaller as we moved closer to 0 on our y-axis, as we moved into the distance and off and into the horizon? Well, our y value is just a number that does that. So maybe we base the length of our tree on y. And let's see what happens here. It looks like that's a little bit too big. Our trees are much, much too big. Well, that makes sense because our y is the first branch is bringing us all the way back up to the top. So, maybe we should scale this down by 100. Oh, and that's much too small, right? So now we're not even seeing some of these things come together. Sometimes making art is an exploratory process, and we tried dividing by 10, and wow, now we're saying the trunk of this tree is going to be where we are on the y-axis divided by 10. And that gives us a nice little, look at those happy little trees growing there in the background. A beautiful little scene we're making here. And if we wanted to take this just one slight step further, we could add a little bit of a randomization here. So maybe we say math.pi/6 plus math.random multiplied by, 0.1. So we add a little bit of entropy here. And now our trees, even if we draw them all at the same y-axis, they're going to have a little bit of variation in them. And you could add more variation in them playing with some of these parameters. So what do you think? We've made a happy little painting here that's got lots of life, just vibrant, coming together. And we did so with a little bit of programming. So I want to thank you for joining me in this episode and in this season of Comp 110. and for making some art with me today here on this last day of class.